All right, guys, let's finish up some of these notes. We're going to be on page 17 of hypothesis testing. We didn't get to this in class, so I wanted to just cover the rest of this. Just for your notes, page 16 we're not going to cover. It's just stuff that we don't have time to in this class, but you can read through it about type 2 error. All right, so page 17 and onward, we're going to talk about what we call two-sample t-tests. This is a hypothesis testing for difference in means. So there are lots of different hypothesis tests, and we don't have enough time to really cover a whole lot more than what we are going to cover. So we covered a one-sample t-test, a one-sample z-test. That's for a test of for proportions. And now we're going to test for a difference between means. Of course, when I record my video myself, I will sneeze. Anyway, so this is a slightly different, and this actually happens all the time. So it's kind of important to pick this one up. And that's basically all we're going to cover for sort of basic hypothesis testing. There's a lot more, a lot of other hypothesis testing. They have the same kind of basic setup. They always have some sort of two hypotheses. You have to decide what the two hypotheses are. You'll always have an alpha. And then you're always going to have a p-value, and we'll always work the same. If p-value is low, we're going to reject our alpha, reject the null hypothesis. So if we can kind of get these 5 steps in our mind, then if we, comes times that we see that there's a different type of test we need, we'll just sort of be able to apply it and still be able to interpret results. So that's what we're after here. All right. So let's go through these notes. So we'll cover one more type of test because it's very common, testing for the difference between two means. In this case, our hypothesis is that there's a difference between two population means. One population might have a special condition, like a coupon is given, or might just be different. Like, do men purchase more trucks than women? So, we've talked a little bit about this in classes. I think I used different examples in different classes, so let me reiterate both of them. So one example would be, do men make more money than women, right? These are two populations. I'm going to collect the data about men and collect data about women and compare these two populations. So this is a difference in means across the two populations. The other example I used in one of the classes, but not in the other, when I was in, who knows, like 3rd, 4th, 5th grade or something like that, I did the science fair project, where really my dad did it all. I didn't really do hardly anything, but we tested the difference between name brand batteries, Energizer Bunny batteries, and Radio Shack batteries, really cheap Radio Shack batteries. My dad built this little device that would connect to our computer, and it would drain the battery a little at a time, and the computer would keep track of when the battery actually died or when it had a really low charge. And so we tested. We were kind of cheap. I think we only tested 4 or 5 of the Energizer batteries until they died, and 4 or 5 of the Radio Shack batteries until they died. Right. So we had 2 different samples here: the Energizer batteries and the Radio Shack batteries. We wanted to compare the average time it took for them to fail across these two different populations. So this is everywhere, right? So I suspect that a lot of your blog assignments, you're going to pick up this idea that there's a difference between means, right? So right now we're just going to look at the difference between two means. We don't have enough time, but there are lots of other tests that say the difference between more than 2 means, right? So what if I have 4 different means? I wanted to test the difference between 4 different types of batteries, right? So Energizer, Duracell, Radio Shack brand, and Costco brand or something like that, right? Well, that would be a different test. That's not what we're going to do now. It's going to be a different type of test. So that's what I mean by saying there's a lot of different kinds of tests that are specific to the type of problem you have. And when it comes time to actually sort of be testing this, that's when you kind of call your statistician friend or buddy that knows a little bit more. Pick up your book. The textbook actually has a lot more in there than we're going to cover. All right, so we're going to do these 2 sample things. So the basic steps are the same. Formulate the null and alternative hypothesis and determine if the test is one or two-sided. Set the sample size and collect the data. And we're going to calculate a test statistic, but the computer's just going to do it for us. So we got to get some sample, find a sample and collect some data. Determine the level of error. So this is our alpha, step 3. Step 4, find the p-value. Again, we're not going to actually do it anymore. The computer will just give us a p-value. And then finally, make the conclusion using the same rule. If the p-value is less than alpha, reject the null hypothesis. So our null hypothesis then up here, not a lot of space up here, but I want to remind you a little bit. We did some stuff that was kind of like this, where we had a difference between two means for probability testing. Remember that? This was like the Bizarro World M&Ms, right? That was the difference between two means. And remember, every time I did that, if I wanted to take the probability that the difference between the new means, I always had to sort of put it in terms of 0, right? I moved them across the site. So I'm going to have likely times some hypothesis that says, it'll be an alternative hypothesis that says something like, battery 1 is less than battery 2. Really, it's going to be the average of battery 1 is less than the average of battery 2. And remember, what we ended up doing was we subtracted battery 2 from both sides, and we said, well, battery 1 minus battery 2 is less than 0. And we're going to do that same thing in these cases, right? So we're going to move things around. So really, that can be rewritten at, let's type, this is really the mu of battery 1 is less than the mu of battery 2. It can be rewritten as the mu of battery 1 minus the mu of battery 2 is less than 0, right? So if that's what we're trying to prove, then we would say, that our null hypothesis would be something like, again, the mu of battery type 1 equals the mu of battery type 2, right? So that would be a null hypothesis. They're the same, but there's no difference. Again, that can be rewritten as the mu of battery 1 minus the mu of battery 2 equals 0. All right, so this is what we're going to end up using, because it turns out that this is no different than sort of this idea of the Bizarro World, the difference between two means problems. Right, so you might go back and look at those notes. So we could actually solve this using our probability tools that we already picked up. The only difference here is, in those cases, we always knew the population standard deviation. So we could use the z, we could use the norm dist function. So now we're sort of moving beyond that and say, well, we hardly ever know that. And so we have to use the t distribution. And so there's some formulas that we could go find a t value. But the formula is kind of long and big, so we're not going to have time to learn it. It's not really hard. It's in the book. Instead, we're just going to let the computer, the data analysis add in Excel, find the t statistic for us, and then find the probability of that t statistic. So in this class, we're going to assume that we always have raw data then. What that means is we're going to actually have the real data in front of us instead of fake problems where we just say, the average of the first battery type was 15 hours, and the average of the second battery type was 17 hours. No, we're going to actually have every single battery, boom, 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 and how long they lasted, and every single battery of battery type 2 and how long they lasted. And then we're going to let Excel data analysis add in do it all. And we only have to do one more thing then, is we have to decide which test to use. So there's actually 3 different types of tests we can do for these 2 sample tests. The first one is that the 2 samples have equal variances, meaning the variance, or we're going to think about like the standard deviation across batteries within each group are the same, right? So that's one way. The other one is they have unequal variances. It doesn't really matter that they have equal or unequal variances. It just matters in the sense that we have to use a different test. There's a little bit different math depending on which one is which. So for these steps 1 and 2, we have to do a test before to determine if the variances are equal, and we'll talk about that. So that's the only kind of tricky thing here. Or the third one is this idea of paired samples. What is a paired sample? Let's read the paragraph, and then I'll talk a little bit more about it. Paired data, or 2 samples that are paired, means that there's some reason to link 2 observations across the 2 populations. So remember, we're going to test 2 different samples, 2 different populations. Our null hypothesis is the mu of one population is greater than the mu of the other population. So if I have some reason to think that there is some observation in each of these 2 populations that's somehow linked to one another, it's like from the same person or the same family or the same town, or there's something to say that those 2 things are the same, then I would say that they're paired, same in some way. So here's an example. If you're trying to test that there's a difference in how high people can jump before and after, so these are my 2 populations, before and after they have a drink of Mike's Super Duper Jumping Tonic, you could measure their jump before, then they drink, and then you measure it after. Right? So now I have 2 measures of the same person, and I do that for a whole bunch of people. And then I say, okay, well, I want to test to see if, the jumping height of before, that's my first population, is different than the jumping height of after, my second population. Okay, well, that's great, except for that's the same person that did both of these jumps, right? So it says your 2 populations would be before the drink and after the drink, and you would create a hypothesis test around these 2 populations. However, the 2 samples have not been independently randomly selected. They're not independently random. Why is that? Well, because there's an observation for each individual in each population, so the data is paired, right? So, like, I find my friend Joe and say, hey, Joe, jump, right? And I measure how he jumped, and I say, here, drink my super-duper jumping tonic. Okay, now jump again. And there he is. So it's Joe is in both of my populations, and so I have to account for the case, the case that he's still Joe, right? And so he is related to himself. He is correlated to himself before and after. So this is what's called paired data. Paired data. All right, so we have to first decide. Here's the steps to do this. First step is to determine if your data is paired. Always decide that. And this, at first, this might be a little bit weird, and you have to question yourself, what paired data, man? What is paired data? What do I mean by paired data? Well, again, any time where I have 2 populations that have nothing to do with one another, it's not the same person, it's not the same thing, then they're not paired, right? So I could actually think of a way to test my super-duper drinking tonic that would not be paired data. So it has nothing to do with the jumping per se. It's just it would be the case that I use the same person, right? So I could just randomly grab people in the hall, flip a coin, and if the coin lands head, then I'm going to give them the tonic, and if the heads lands tails, then I'm not going to give them the tonic, and then I'm going to ask them to jump, right? So half my population would jump with the tonic, and half the population would jump without the tonic. If I did that, then it would not be paired data, right? Because half the people that jumped who had the tonic had nothing to do with half the people who jumped that did not have the tonic. So paired data is the first step. Determine if they're paired. If you determine that they are paired, then we're going to use this test called the Ttest, Paired 2-Sample for Means test. Right, we're just going to jump right to that and use that. This is the data analysis test in the data analysis add-in. If you say, okay, they're not paired, then we have to determine whether or not the variances are different. Remember, there's 2 tests we have to, at the end of the day, we're going to say, well, the variances have equal variances, or the samples have equal variances, or the samples have unequal variances. We have to decide which of these 2 tests to use. If we say, no, it's not paired data, okay, then these are my 2 choices. So in order to do that, we have to run a separate hypothesis test. This is sort of a hypothesis test embedded in another hypothesis test. So this gets a little bit crazy, but not really too bad. So in this case, we're going to run this test called an Ftest 2-sample for variance. All this does is compare the variance across my 2 samples to say, are these 2 variances the same? If they are, then we're going to use the Ttest, the Ttest assuming equal variances. If they're not, then we're going to assume the Ttest for unequal variances, right? So this Ftest, we've never actually run an Ftest. This does not give us the answer to our original hypothesis. It gives us an answer to a new hypothesis that we have to to determine which Ttest to use. So in this test, the null hypothesis is that variances are equal. The null hypothesis is that they are equal. Right, so we already assume that they are equal unless we have a really low p-value for this Ftest. Then we continue to assume that the variances are equal. If we do get a low p-value, then we say, well, they're not equal. They must be unequal. So the p-value for the Ftest for 2-sample variances is low, and we're going to say less than 0.05. We'll always use that, less than 0.05. Then we assume the variances are not equal, since you can reject the null that they are equal, and use the Ttest 2-sample assuming unequal variances. If the p-value for this Ftest 2-sample for variance is not low, that's higher than 0.05, then you'd assume the variances are equal, since you cannot reject the null hypothesis that they are equal. So we use the Ttest 2-sample assuming equal variances. So here, let me zoom out a little bit. Here is sort of the big picture of what I just talked about. So the first question we're going to ask ourselves are the samples paired? All right, what does paired data mean? What is paired data? Oh yeah, paired data means I get the same person or the same thing doing things in both population. The measurement of my things in both populations have some correlation to one another. Some correlation to one another. If they are paired, okay, good. I'm just using this Ttest paired to sample for means. If they're not paired, then I got to go down this route, right? So if they're paired, poop, I'll just go right here and I'm done. The only ones that really matter are these ones at the bottom, the red. If they're not, then I have to do this little sub-hypothesis. Sub-hypothesis says, okay, first run this Ftest to sample for variance. All this Ftest does is tell me is the samples have equal variance or unequal variance, right? And I say, well, if the p-value of this guy is really low, lower than 0.05, if it is low, yes, it is low, then use this to sample assuming unequal variance. If the p-value is not low, then I use this Ftest to sample assuming equal variances. And that's it. So remember, though, these guys on the ends here, these are the ones that really matter. But sometimes we got to run this one in the middle. When I say really matter, I mean we'll answer our difference in means hypotheses. We're going to get a p-value here in the middle, but that doesn't actually give us the p-value that we really care about. The only reason we do this p-value is to determine which test to use at the end of the day. So I get too confused. We're going to get two p-values here. So don't just run this guy and say, oh, I'm done. The p-value is low, so my two samples, I can reject the null hypothesis of my original hypothesis. No. All that does is it tells us which of these two tests to run. Okay, we're almost done. The process for running these 4 tests are all identical. We just find the right test under the data analysis, put the 2 samples in appropriate places. When it asks for expected differences, put whatever is in your null hypothesis. Usually this is going to be 0, since we're usually determining that the difference is bigger or smaller than nothing, right? So a couple pages back. So remember, here's our null hypothesis. The mu of the battery 1 minus mu of battery 2 equals 0. This is my null hypothesis. This is the expected difference. Sometimes it's not 0. Sometimes it's something other than 0, but almost always it's 0. All right, so this is what you'll see when you start running this. It's going to ask you for what you suspect the difference is going to be, 0. If the difference is bigger and smaller or nothing. So the default is 0, so if you don't put anything in there, you're good to go. The test results will show a p-value for both one-tail and two-tail test. So it's going to give you p-values for both of those. So you have to choose the appropriate one the same way we did before. So that's it. So there's another video of me running some of these in Excel, and then we're going to do some more of these in class as well. And you got some homework too. The homework, so there's some homework in this. Okay, so that's the end of these notes. Thanks.